Have you ever touched a hot pizza box and thought, ouch, that's hot? What if I told you that the same heat making your fingers warm could also power your video games? It sounds like something out of a science fiction movie, doesn't it? But it's totally real. We're surrounded by heat every single day. The sun warms the sidewalk, your car's engine gets toasty. Even your own body is like a little furnace. Imagine if we could capture all that wasted heat and turn it into something useful, like electricity. That would be a game changer for how we power our world, making energy cleaner and more available for everyone to use. This amazing trick isn't magic, it's science. It's all about finding a clever way to connect the world of hot things with the world of electricity. Think about it. Heat is a form of energy. Electricity is another form of energy. Researchers have been working for a long time to figure out how to convert one into the other. It's like being a translator who can speak two different languages. In this case, the languages are heat energy and electrical energy. This special scientific translation process allows us to do some truly incredible things, like powering spaceships that are millions of miles away from the nearest outlet. So how does this incredible conversion happen? It relies on special materials that have a superpower. These materials don't look like much. They might just seem like a boring piece of ceramic. But when one side of this material gets hot and the other side stays cool, something amazing begins to happen inside. It creates a temperature difference, or what scientists call a temperature gradient. Okay, get ready for the official name of this amazing science trick. It's called the thermoelectric effect. That might sound like a big, complicated term, but let's break it down. Thermo means heat, like in the word thermometer. Electric means electricity. So the thermoelectric effect is basically turning heat into electricity. It's a natural phenomenon in certain special materials. These materials are the superheroes of the story. Unlike normal materials like wood or plastic, they can turn heat directly into electricity. These special materials are called thermoelectric materials. Imagine a tiny block made of this stuff. Inside, it's full of little particles called electrons. When you heat one side of the block, the electrons on that side get super energized. They start wiggling and jiggling with excitement. They want to move and spread out. That starts a chain reaction that creates an electrical current. That current can power things. But you need both a hot side and a cold side, not just heating the whole block. The electrons need somewhere to go. The cold side is a calm, quiet place the electrons escape to. Think of a crowded, noisy room next to an empty, quiet room. People move to the empty room. The temperature difference pushes electrons from hot to cold. It's a three-step process. First, a thermoelectric material. Second, create a hot side and a cold side. Third, electrons move in an organized way. Let's zoom in and see what's really happening inside our special material. Everything is made of atoms. Inside those atoms are even tinier particles called electrons. You can think of these electrons as tiny dancers at a party. When you heat one side of the material, it's like turning up the music on that side of the dance floor. The electrons there get a huge burst of energy and start dancing like crazy. They're bouncing around, full of kinetic energy. The dance floor on their side starts to feel very, very crowded. They have too much energy to stay in one place. Now, remember how our material has a cold side? That side is like a quiet corner of the dance floor where the music is much softer. The electrons over there are calm and relaxed, just chilling out. The super-energized electrons from the hot side see this quiet, empty space and decide to move over there. They start flowing in a single direction, away from the heat and toward the cold. This flow is not random. It's an organized parade of electrons marching from the hot end to the cold end. This organized movement is the most important part of the entire process. This parade of moving electrons is what we call an electric current. It's the very same electricity that flows through the wires in your walls to power your lights and charge your phone. To make it useful, we just need to connect a wire to the hot side and another wire to the cold side, creating a complete path or a circuit. Once the circuit is complete, the flowing electrons can travel through it and do work, like lighting up a tiny LED bulb or charging a small battery. One of the most amazing examples is in outer space. Spacecraft like NASA's Voyager probes are too far from the sun to use solar panels. So how do they get power? They use a special device called a radioisotope thermoelectric generator, or RTG. It uses the heat from decaying radioactive material to create electricity. The hot material provides the thermo, and the cold vacuum of space provides the cold, allowing the probes to keep sending us data for decades. But you don't have to go to deep space to find this technology. It's getting closer to our everyday lives. Imagine wearing a watch or a fitness tracker that you never have to charge. Scientists are developing wearables that use your body heat to power themselves. Your skin is naturally warm, about 99 degrees Fahrenheit or 37 degrees Celsius, while the air around you is usually cooler. A small thermoelectric generator in the device can use that difference to keep it running. It's like having a personal power plant on your wrist, powered by you. Another big area is our cars. A typical car engine gets extremely hot, and most of that heat is wasted out the exhaust. What if we could capture it? Researchers are designing thermoelectric generators that wrap around a car's hot exhaust. The device uses the hot exhaust side and the cooler outside air side to generate electricity. That electricity could help power the car's radio lights and air conditioning, meaning the engine does less work and burns less fuel. From powering rovers on Mars to making our cars more efficient, the thermoelectric effect is a simple but powerful idea with a bright future. Energy isn't lost, it just changes form. We can capture waste energy and turn it into something valuable. Turning heat into electricity is more than fun science. It's a pathway to a smarter, more sustainable world, all thanks to a tiny dance party of electrons moving from hot to cold. Now that's what I call wonder.